Hello, everybody. This is Chris Forbes again here with your next Math 1 lesson. We are in day 2, continuing part 2 of the first video. Today we're going to be talking about equations and their solutions. Alright, so as usual we will start off with our objective in the box there, and we will continue from there. So, equations and their solutions. So students today will be able to find solutions to equations. Alright, so we're going to find the solutions to an equation, which we already learned what an equation is. In order to, we're going to interpret the meaning in the context of the problem. So not only are we going to find the solution to the problem, we're also going to figure out what that means in the context of a problem, because that's what equations represent. Alright? So, remember the two things with this is, number one, my handwriting is god-awful, so I apologize for that. I am getting better. And number two, the whole structure of these notes is for you to attempt it on your own first, okay? This is only for me to explain after you have already attempted it, okay? So, as always, before I go through any problem, I encourage you to try these problems on your own, see what you can figure out, use me as a last resort, okay? Alright, so it says a granola bite contains 27 calories. Whoops, don't know why I did that. It says a granola bite contains 27 calories. Most of the calories come from C grams of carbohydrates. Okay, the rest comes from, well, other ingredients. 1 gram of carbohydrates or carbs contains 4 calories. So I know that 1 gram has 4 calories and this snack has 27 calories total. Alright, the equation 4c plus 5 equals 27 is going to represent this relationship between these quantities. So there's our equation. Alright, well, what could the 5 represent in this situation? Alright, let's break this down. We got 4c plus 5 equals 27. Alrighty, well, the 4c, alright, what does the 4c represent? Well, remember, c is the grams and 4 is the calories, so this is telling us how many calories for each gram of carbs. Okay, so there's my calories for the grams of carbs. Here is my total calories. Alright, well, if that's the total calories and this is the calories of the carbs, then this must be the rest from the other ingredients, where it says it right there. So the 5 is the calories from my other ingredients. Boom. Alright, so what could the 5 represent in this situation? Well, it could mean really any of the other ingredients, right? So this is the calories from other ingredients, whatever those ingredients are. Okay, so understanding how to break down the equation. All right, number 2. Priya said that neither 8 nor 3 could be the solution to the equation. Explain why she is correct. Alright, remember, this is our equation right here. If we're talking about a solution, it means the value that I can plug in for C. Alright, what is C? That's going to make this equation true. Alright, well, Priya's saying that 8 nor 3 could work. Well, let's explain why. If I plug 8 in for C, so instead of C, I plug in 8, and I add 5, does that equal 27? Well, use your calculator, do it by your, in your head, but 4 times 8 is 32. 32 plus 5 is 37, which does not equal 27. So far, she's right. 8 cannot work. What about 3? Well, 4 times 3 plus 5 equals 27. That's 4 times 3 is 12 plus 5 equals 27, but really that is saying 17 equals 27, which is not true. So again, Priya's right, that's why. Okay, that is not the solution. Well, then what about in 3? Find the solution to the equation. Well, how do I do that? Alright, well, if I got 4c plus 5 equals 27, if we ever need to solve for a variable, it's all about getting that variable by itself, right? So in order to do that, we need to, I always say, kind of start from the outside in, all right? Do the operation farthest away from C. So let me try to do this real quick. Let me try to change the color if I can. So if we got plus 5 right here, the opposite of plus is minus, okay? Now I always kind of draw a line right here through my equal sign. So if I'm subtracting 5 on this side, I also have to do it on this side. So those go away, and I'm left with 22 equals, and then what's left over is that 4C. So right now I got 4C equals, I'm supposed to say 22, but my handwriting's awful. All right, and then how do I solve for C? Well, if I got 4C equals 22, I'm going to divide both sides by 4 because they're multiplying. So we're going to divide both sides by 4, and we get C equals 22 over 4, which I believe is 5.5. All right, just double checking my work on my calculator here. Yeah, that's what I got, 5.5. Okay. All right, so again, pause the video, process that, try that on your own. Again, you're pausing the video, you're going to try the next equation word problem on your own, okay? So, weekend earnings. It says that Jada has time on the weekends to earn some money. A local bookstore is looking for someone to help sort books and will pay $12.50 every hour. To get to and from the bookstore on a workday, however, Jada has to spend $7.15 on bus fare. All right, that makes sense in the real world. Okay, so you know you're earning $12.20 an hour, but there's always expenses you have to have. In this case, there's $7.15 for a bus fare. Okay, so the last problem gave us the equation, but now I want us to write an equation that represents Jada's take-home earnings in dollars E if she works at the bookstore for H hours in one day, okay? And we got to use the information it gave us. $12.20 an hour, there's our H, and $7.15 for a bus fare, okay? So, it wants to know the earnings E. All right, we're going to put a little E right here for our earnings. And what does that equal? All right, well, I know it's $12.20 for every hour. So how we put that is $12.20 for every hour. So you multiply by the hours. So if she works 5 hours, it's 5 times $12.20. But don't forget, we have to pay a flat rate of $7.15 for bus fare every day. All right, so we're just going to subtract, not add, but we're going to subtract out that $7.15 an hour. Okay, so this is what I make, this is what I have to pay, and that will give us our total equation. All right. Again, pause the video at any time, but we're going to keep on tracking. It says, okay, one day, well, Jada takes home $90.45 after working H hours and after paying the bus fare. All right, well, there's not an equation here, but or not a question here, but what I want us to do is write the equation that represents that. Okay. So take you a second, again, pause the video, see if you can write the equation that represents this situation in number 2. All right. Well, 90.45 is how much she has earned, so we're going to make that our E value. All right, and we don't know how much she worked to get that, so instead of writing E like we did in number 1, we're going to write 90.45 equals, and then the $12.20 per hour, all right, minus the $7.15 bus fare. So if I were to find the solution H for this, then I would know how many hours it took for her to make $90.45. But again, all I wanted us to do in number 2 is just write the equation. All right, we solved for the equation in the first problem. If you really want to do it on your own in this problem, go for it. Okay. Now, so kind of like the first problem, is 4 a solution to the last equation you wrote? So is 4 an equation to the equation I just wrote in number 2? Would 4 work in that particular case? And what about 7? Well, if we want to find out, all we got to do is plug 4 in for the hours and plug 7 in for the hours and see if we get $90.45. All right. So I'm going to write $12.20 an hour. Well, I worked 4 hours, and then minus the $7.15. Okay. Again, type that in your calculator. All right. Give you a second to do that, but when I typed it in, I got $41.65. Okay, which does not equal $90.45. Meaning, she worked more than 4 hours to get the $90.45. Right. All right. What about if I plugged in, instead of 4 hours, what if I plugged in 7 hours? Minus the 7.15. Oops, that should be a minus, not an equals. 7.15. All right, when I type that in the calculator, I get $78.25, which again does not equal 90.45. It's a little bit less than 90.45. So I'm assuming that Jada had worked more than 7 hours to get to $90.45. So she had a long work day. Okay. All right, moving right along. Now, number 4, in this situation, what does the solution to the equation tell us? So again, I'm not asking you to actually find the solution like we did in the last problem, but if I were to find the solution, number 2, what does that mean? Well, it tells us the number of hours Jada worked to take home $90.45. So it's the number of hours Jada worked to take home $90.45 after the bus fare and all the good stuff. Okay, understanding what the solution means in the context of the problem. All right, let's do one more. And again, pause video, try this on your own, but let's see if we can do this equation and understand what this means. All right, 1 gram of protein contains 4 calories. 1 gram of fat contains 9 calories. So we know that 1 gram of protein is 4 calories, 1 gram of fat is 9 calories. Well, snack has a total of 60 calories from P grams of protein and F grams of fat. All right, so I gave you the equation. Maybe you can come up with it on your own if you didn't see it already, but that's 4 calories for every gram of protein plus 9 calories for every gram of fat equals 60. That represents the relationship between these quantities that we just talked about. So, determine if each pair value could be the number of grams of protein and fat in the snack. Be prepared to explain your reasoning. So we've done a number of these problems already. What if I had 5 grams of protein, which we're going to call P, and 2 grams of fat, which we're going to call F? Does that make us have 60 calorie snack? Does that work? Is that solution to this equation? Well, let's try it. That's oops, that's supposed to be a 4. Remember, the equation's 4P plus 9F. So 4, and in this case P is 5, plus 9, and in this case F is 2. Does that equal 60? Alright. Well, it's 20 plus 18, which equals 38. So this does not work. This is a no. Again, pause the video, try the other 2 on your own. Try the other 2 on your own. Again, 10.5 grams of protein, so that's going to be 4 instead of P. I'm going to do 10.5 plus 9 instead of F. I'm going to say 2. All right, that's going to end up being, if you do it in your calculator, 42 plus 18, which is equal to 60. So that does work. So this potentially could be a solution to the equation. And what about C? All right, this should be pretty straightforward at this point. 4 times 8 for the protein plus 9 times F, which is 4 for the fat. What does that equal? Well, that's 32. That is, what's 9 times 4? Yeah, 36 for a total of 68, which does not equal 60. All right, number 2. If there are 6 grams of fat in the snack, how many grams of protein are there? Show your reasoning. All right, well, remember, we got the equation. Remember, it's 4P plus 9F equals 60. That's our relationship. That's what we're using. You got to understand what that means in the context of your problem. Well, it's saying that we have 6 grams of fat. So that's our F. Okay, so I know that F is now 6. And it's asking us for the grams of protein, which in this case is P. So I have an equation with all variables known but one. I can solve for P like I've done before. Okay. All right. First things first, we're going to simplify. 4P plus 9 times 6 is 54 equals 60. Now, just like before, we see plus 54. Now we're going to say minus 54. And whatever we do on one side, we have to do on the other. So I'm going to write it up here. We get 4P equals, well, 54 minus 54, that goes bye-bye. That's the whole point. And then 60 minus 54 is 6. All right. Then we're going to divide both sides by 4 since we were multiplying. And we get P equals whatever 6 divided by 4 is, which is 1.5 grams. Make sure you put the unit. Solution. What does the solution to the equation 4P plus 9F equals 60 tell us? Give an example of the solution. Alright, well, simply put, it means that a pair of grams of protein and fat in the snack that adds up to 60 calories. We already know that. And there's a bunch of different equations that could possibly work, or values that could work. So I'll give you an example. Just trial and error, we know that if I said P equals 6 grams, and I say that F equals 4 grams, that's a potential answer, because 4 times 6 plus 9 times 4 does equal 60. So we're good there. All right. Now, for the summary. You can fill in the blanks. You can just pay attention. I went ahead and wrote them down to save us some time. But essentially, this is all that we're saying right here. Just to summarize what we've learned. An equation that contains only one unknown quantity or one quantity that can vary is called an equation in one variable. For example, the equation 2L plus 2W equals 72 represents the relationship between length and width of a rectangle that has a perimeter of 72 units. If we know that the length is 15 units, we can rewrite the equation as 2 times 15 plus 2W equals 72, where we simply plugged 15 in for our length. This is an equation in one variable because W is the only quantity that we did not know. And then to solve for W, or to find the value of W that makes the equation true. In this case, 21 is the solution because substituting 21 for W in the equation results in a true statement. So instead of a W, if we plugged in a 21 and wrote that in our calculator, we do get 72. An equation that contains two unknown quantities, or two quantities that vary, is called an equation in two variable. Pretty straightforward. A solution to such an equation is a pair of numbers that makes the equation true. So here's an example right here. Suppose Tyler spends $45 on t-shirts and socks. A t-shirt costs $10 and a pair of socks costs $2.50. If T represents the number of t-shirts and P represents the number of pairs of socks that Tyler buys, we can represent this situation with the equation 10T plus 250P equals 45. Just like the problems we did earlier. Now, this is an equation in two variables. We have two variables to solve for. We have T that represents the number of t-shirts and P that represents the number of pairs of socks. So there's a bunch of numbers that can make that work. For instance, T equals 3 and P equals 6 does. T equals 4 and P equals 2 does. And so does T equals 2 and P equals 10 does. In this situation, one constraint is that the combined cost of shirts and socks must equal $45. You can see that above right here. It says that Tyler spends $45 on tees and socks, and we talked about what constraints were last video. Solutions to the equations are pairs of T and P values that satisfy this constraint. Combinations such as T equals 1 and P equals 10, or T equals 2 and P equals 7 are not solutions because they don't meet the constraint. Meaning, if I plugged 1 in, and if I plugged 10 in, I get 35 and not 45. When these pairs of values are substituted into the equation, they result in statements that are false. Alright, quickly went through the summary there, but that's the beauty of a video. You can pause and replay as much as you need to. And that does it for equations and interpreting their meanings in the context of a problem. Alright, so thank you guys. I hope everybody has a fantastic day and a great week, and I will talk to you soon. Goodbye.